The conic, probably the conic you're most familiar with outside of the circle, is the parabola. Now, when you normally think of parabola, you're usually thinking of something like y equals x squared, and it's shifted over. But parabolas actually have um, very specific ways of being described that don't have necessarily anything to do with one being a function of the other, though it can be written that way, but you can generalize it with some specific points. So the definition really is that what I can do is if I take a line and then I take a point in space that's not on that line. So take a line, any line, any straight line, and any point in space, and then I take the perpendicular line, the line perpendicular to the purple line here through that point, right? So you can't go this way. It has to be aligned so that it's perpendicular. So if I take the axis through that, once I do that, if I think about all of the points where the distance from the line and the distance to the point are exactly the same, that describes a parabola. So what am I saying? I'm saying that if I moved the focus up, then it would bring in the parabola, because it would have to come further away from the line because it has to go further towards the focus. So that focus there, as I drag it up, makes it thinner. As I pull it down, flattens it out. And so that's the idea, is that you can think of that as sort of a bead on a string that pulls it, right? And so you have this very specific definition. Notice that when we did that, technically we have these points x, y, but realistically we're thinking about this the way you would think about a geometric problem, where you're describing this idea of this locus of points, where certain things are related to these geometric constructs, in this case a point and a line. So it's kind of interesting. It's kind of a neat way to describe a concept that doesn't use the algebraic form. However, the algebraic form is something we want to use because we want to eventually think about the calculus of this. But if we use this idea of this directrix and this focus, and then of course there's this idea of a vertex, and the vertex is really the point that's closest to the directrix, if you could think of it that way, right? Of the points there, it's the one that lies along the axis, is another way to think about it, or you could think about it as the one that's closest to the directrix. So if we think about things in terms of that vertex, and we call that h and k, like we have been already. So if I have some vertex, which is h and k, so think of it like we thought about the center of an ellipse or the center of a circle, but in this case it's a vertex. Then I have two forms. Notice in this case the x term has a squared, in this case the y term has a squared. So if the x term is squared, that's what you think about the standard parabola. That's what we call a vertical parabola. That's this type of thing. It just opens up. Now, in the case where the y is squared, that's a horizontal parabola. So instead of opening upward, it opens outward, right? So you can think of it kind of taking and just kicking over. And so or it could go this way depending on how how everything's set up. So anyway, now I have this, and I have this weird p here. Well, what we find is there's a relationship between the vertex, the focus, and the directrix, and that p is that relationship. So these are the shifts, and this p says, okay, in the case of the vertical parabola, k is, or the directrix is p units away from the vertex point, right? If it's hk here, there's a horizontal line that's p units below it. So this distance is that p value. And what you also notice is that this distance is this p value. So you subtract and you add, right? You see that you add it here, you subtract it there. And similarly, you subtract it here and add it there. So this distance and this distance are the same, which is only natural because definitionally they're equidistant, right? So definitionally, if this is on the curve, it has to be the same distance from those 2 points. So what does all this mean? Well, this means that we have these categories, and as long as we can take whatever equation we start with and make it look like one of these forms, we just have to fill it out find which one is which, and then go from there. Don't overthink this kind of stuff. This kind of stuff it's not the type of thing that you're supposed to just memorize and do. Now, if you do this all the time, you do this for particular applications, fine, memorize it. But this is not that type of thing. This is one of those things where you have a table of values and you fit it to a form, and then you go, okay, this pattern matches this, pull out these parameters, boom, go. That's what this is supposed to be. It's not supposed to punish you. It's not supposed to grind you into the dust like conics sometimes do. So what we want to do is there's a 4-step process for graphing this sort of thing. The first thing is to determine the axis. What does that mean? Well, if it's a parabola, find which one is squared. If the x term is squared, it's a vertical axis. If the y term is squared, it's a horizontal axis. So that's the first thing you want to do. The second thing you need to do is find p. So you need to get it in this type of form if it's not already there. So, for instance, if I have 2 times x minus 3 minus y plus 7 squared equals 0. Well, that's not in either of these forms. But what I do know is that the y term is squared. So I know I'm dealing with a horizontal parabola. So now I'm dealing with horizontal. So I've got to get some term times x minus h. So I move that over. I get that on this side. Now I have 2 times x minus 3. But I need 4 times a number. I have 2, but I need 4 times a number. So 2 is 4 times 1/2. So now I have 4p x minus a number equals y minus a number squared. Now you might say, okay, well that's y plus 7. Yeah, but that's y minus -7, right? That's how we always do that sort of thing. You rewrite it conveniently. The form is y minus something. So if you have y plus, you write y minus the negative something. So this would be y minus -7. So that tells me that my center, or my vertex, is at 3, -7. So you're really looking for what makes these things 0. And then you get p is equal to 1/2. So now you've found p. And now we really just want to fill out the chart. Now I already kind of did that by doing h and k here. But look at the chart. Okay, all right, I got a directrix. I got to find my vertex, my directrix, and my focus. But I've got h, I've got k, and I've got p. So I automatically say, okay, well, focus is, okay, we got a horizontal one. So you got to keep track. So then I go h, well, h is 3, p is 1/2. So my focus is 3 plus 1/2. So right there's 7 halves. And then k, we already know what k is. K is -7. So I'm just filling this thing out. Now my directrix is h minus p. So then I have to say, all right, 3 minus 1/2. Well, that's 5 halves. Okay. Now I've got a focus. Now I've got a directrix. So the directrix, notice this is a line. So I go to x equals 5 halves. I draw the line. I have a vertex. That's 3, -7. I'm going to plot that point. I have a focus, which is 7 halves -7, which is that point. So I've now plotted the focus. I've plotted the vertex. I've plotted the directrix. It looks like it makes sense because the distance there match. And then finally, plot points as needed. So I sort of just drew a parabola. It actually almost looks more like a hyperbola, so don't get on me too much. Things you might want to do would be, let's plot some other points, right? So I say, okay, well, what do I need to do? What about when, like, x is 4? So I could go to this thing, and I say when x is 4, that's going to be 2 times 1 equals y plus 7 squared. So 2, square root of 2 is y plus 7. And then really you kind of get that plus or minus situation here. And so 7 plus or minus square root of 2 is equal to y. So your points are going to be 4, 7 plus square root of 2, 4, 7 minus square root of 2. And those would be points you would plot. So, you'd have like 4, like here and there, And you plot points as you need to, because it can be kind of hard. You got to fill this thing out. But those are really your big keys here. If it's already somewhere even near standard form, you may have to factor some things, but at the end of the day, it's not a hard process. The key is follow the chart. You follow the chart, you're gonna be fine.